Picture a car driving itself down a busy street. It needs to find every pedestrian, every other vehicle, every sign, and it needs to do it dozens of times a second, or the whole thing is useless. Back in 2015, Redmon and colleagues published a detector with a memorable name, You Only Look Once, and it made that kind of instant, real-time detection genuinely practical. The trick was to stop looking at an image piece by piece and start looking at all of it at once. Here's exactly how that works. To appreciate what Yolo changed, look at how detectors worked right before it. Earlier detectors ran in two stages and they were slow. First, they'd propose thousands of candidate regions where an object might be. Then they'd run a classifier separately on each and every one of those boxes. That meant firing the network thousands of times for a single image, which is fine for a photo but hopeless for live video. Yolo throws that whole pipeline out. Instead of proposing regions and classifying them one by one, it reframes detection as a single regression problem, solved in one forward pass over the entire image. The network looks once, sees everything together, and reads out every object at the same time. That's where the speed comes from. So how does looking just once actually produce a complete set of detections across the whole image? Follow along through the 4 steps. First, Yolo overlays a grid on the image, splitting it into cells. Each cell becomes responsible for detecting objects whose center falls inside it. This simple division is what lets the whole picture be handled in one shot. Then every grid cell makes its predictions directly. It outputs a set of bounding boxes with their position, width, and height, a confidence score for each box, and the class probabilities. All of that comes out together from a single pass of the network. Next comes the cleanup. Many cells will fire on the same object, so you get overlapping boxes. A filtering step keeps the most confident box and merges or drops the redundant ones, so each real object ends up with just one clean detection. And finally, out come all the detections at once, boxes and labels drawn across the whole frame together. Because that entire journey took just one look at the image, Yolo can turn around and repeat it dozens of times a second on live streaming video. Let's pull out the 3 ideas that make Yolo tick, and one honest trade-off. The first idea is detection as a single regression. Rather than a chain of propose then classify steps, Yolo learns to map straight from raw pixels to boxes and labels in one pass. That unified design is the beating heart of the whole approach. The second idea is that the grid does the work. Dividing the image into cells and letting each cell predict boxes, confidence, and classes is what makes it possible to cover the entire frame simultaneously, without any separate region proposal stage bolted on. The third idea is real-time speed with global context. Seeing the whole image at once means fewer background false positives, and running at dozens of frames per second makes it usable for video and robotics. The old trade-off was weaker accuracy on small, clustered objects, steadily improved across many versions since. Okay, let's lock in the 4 things worth carrying away about Yolo. First, Yolo stands for You Only Look Once, introduced by Redmon and colleagues in 2015, and it made real-time object detection practical. Second, older detectors were 2-stage and slow, proposing many regions and then classifying each one separately, thousands of passes per image. Third, Yolo reframes detection as one regression over a grid, where each cell predicts boxes, confidence, and classes all at once. Fourth, that single look is what buys real-time speed with global context. If breaking down architectures like this is your thing, Standarity.com has a growing shelf of them waiting for you. Go take a look.